Hi, this video is for homework 11, question 1. Question 1 asks us to solve that if the stochastic process xt is real WSS with autocorrelation Rxs tau and power spectral density Sxs omega. We need to show that a Rxs tau is real and even. B Sxs omega is even and non-negative. So for question A, we know that xt is WSS. So the correlation, autocorrelation, Rxx tau equals expected value capital Xt plus tau times xt. This is real. And Rxs tau equals Rxx t plus tau t, which is expected value xt plus tau t xt, which is xt times xt plus tau. This is equals to Rxx tau t plus tau, and this is equals to Rxs minus tau. So Rxs tau is even. And we need to show that the spectral density is even and non-negative. So here, Sxs omega equals the integral from minus infinity and to infinity. Rxs tau e to the power of s minus j omega tau with respect to tau, and this equals to this cosine omega tau d tau plus minus j times the integral from negative infinity to positive infinity Rxs tau sine omega tau with respect to tau. And as you can see, this is an odd. This is even. Yeah, we just proved here this is even. So this is even, and sine omega tau is an odd function. So the whole part of this is an odd function. So the result is 0 for this integral. So this should be equals to 2 times integral from 0 to positive infinity Rx tau cosine omega tau with respect to tau. This should be equals to Rxx tau cosine minus omega tau with respect to tau. This should be equal to xx minus tau omega. So we know that Sxx omega is even. And I'll show an example to show that Sxx is non-negative. Here, as you can see, if a process xt, which is WFS, goes through h omega, and the output is yt. here we suppose that h omega is ideal in band pass system. So h omega is 1 0 omega 1 omega 2. Otherwise we need to find y, the absolute value of yt square, and this should be equals expected value of absolute value of yt square is greater or equals to 1, and this should be equals to 1 over 2 pi times the integral from minus infinity to positive infinity h omega square as xx omega with respect to omega, and this should be equals to 1 over 2 pi from omega 1 to omega 2 as xx omega with respect to omega. So we can see that the area of fsxx omega in any interval is non-negative. This is only possible only if s omega is greater than 0 everywhere. So we have proved this.